Right, welcome to the Maths Master Cluster. Today we're looking at the previous paper, which was written in 2025 in KZN. Right, okay. So we're focusing on Euclidean geometry. Now, let's look at the statement. In the diagram, O is the center of the circle. We have O, which is the center of the circle, and then we have of the circle A, B, C, D, E, right? And then we have CE, which it is a diameter. We have CE here, which is our diameter, and then again AB parallel to EC. We have AB, which is parallel to EC, and then those are our parallel lines, right? Okay, and then OD, it is also drawn. And then also we have angle C, which is 26 degrees. So we have our angle C here, which is 26 degrees. Just gonna erase that. We have our angle C, which is 26 degrees. Okay. So now they want you to write with reasons the angle that equal 26 degrees, and then the angles that are equal to 26 degrees, which is angle C, the other three angles. Okay, let's take a look. We are given the parallel line. Given the parallel line EC, it is parallel to BC, and then we have alternating angles. So that simply A2, it will be equal to angle C. Let's take it down. Angle A2 will be equal to angle C, which is equal to 26 degrees. And then the reason will be the alternate angles are equal, because we were given that AB, it is parallel to EC. Okay, and then now again we have this angle A2. Let's write it down. Angle A2, angle A2, which is equal to angle A, which is equal to angle A2. Why? Because they're subtended by the same arc BC. They're subtended by the same arc BC. So now this angle is subtended by that arc BC, and also if we can look at from this perspective, it is still subtended by the same arc BC, right? Okay, right, arc BC. Then we have our angle A2, which is equal to that. Angle A2, which is equal to angle E2. That is equal to 26 degrees. The reason is angle in the same segment. Or angle subtended by the same arc. Right. And then from there now, we still have alternate angles drawn from here, going down, coming up here. Now, because remember AB, it is parallel to EC, then that means angle B1, it will be equal to angle E2. So in that case, now I'm going to have angle B1 to be equal to angle E2. Angle E2. That both of them are equal to 26 degrees. Then reason is alt angles are equal because AB, it is parallel to EC. AB, it is parallel to EC. Right? Okay. So now we can also see that angle B1 will be equal to angle C. Why? Because they're in the same segment. Also B1, you can see B1. Oh, we've already given that. B1 is equals to 26 degrees, angle in the same segment. Right. Okay. That was the first question, 8.1. And then now going to 8.2, calculate the size of O1. We want the size of O1. Now the size of O1, let's look at it. Right? The size of O1, if we can look at O1 from this perspective, we'll see that angle O1, it is twice the angle at the circumference. Or we can look at it from this direction, angle at the center, which is this. It will be 2 times angle at the circumference. Okay, that back, we have angle at the center. Right. Let's now calculate the angles and see. Right, we have this angle here, it's 57, and that is 28. What does that implies to us? 57,8 divided by 2. It gives us angle at the center. Or we can say 28,9 multiplied by 2. It gives us angle at the center. Angle at the center, it is 2 times the angle at the circumference. And the angle, it's 27,7. Here it's 55,5. So now, let's look at what do we get when we say angle at the center. 27,7 times 2, it is 55,4. So the angle at the center, it is 2 times the angle at the circumference. Okay, now let's go back to our equation. So now we can now safely say that angle O1, it will be equal to 2 times, you can either say angle A2 or angle E2. You can say A2, then your reason in that case will be angle at center. Angle at center, it is equal to 2 times angle at the circumference. Right, then that will be equal to 2 times 26 degrees. That will give you 52 degrees. Right, that will give you 52 degrees. Okay, so now coming back to the same question again, we have B now. Calculate the size of B angle DE. So we're looking for B angle DE. So now to calculate that, we're going to say we now have AE coming that side, DB, that it is a cyclic quad. And we know that from that cyclic quad, when we take angle A1 plus angle A2, angle A1, we got it, which it is 90. Why it's angle A1 90 degrees? Because EC, it is a diameter, and a diameter, it subtends 90 degrees. So it means here we're going to have a 90 degree, and then plus 26 A2, it is proven above, that will be 26. And then when we add the 2, we're going to get 116 degrees, right? So going to the question now, we're going to have B angle AE. When we add it with B angle DE, they give us 180. Why are we saying they give us 180? Because it is a cyclic quadrilateral, the cyclic quad. And then BAE, we have 116 degrees with plus B angle DE, which is 180. And you must state your reason here that opposite angle of a cyclic quad are supplementary, right? Okay, then you'll see that your B angle DE will be equal to 180 subtract 116. That will give us, let's see, 180 minus 116, that will give us 64. Then we'll have 64 degrees. So that is our angle of BDE. So the whole of this angle will give us 64 degrees. Okay, now let's look at 9.1. It's proven. It is there on the YouTube video. YouTube under the Maths Master Plaster. Maths Master